Hey, um, all right. So here's kind of what we're looking at. I had a couple people that had asked for maybe just some short little videos to kind of help you guys go through and review. I guess my plan is over the next probably day or two, I'm going to be kind of releasing two or three. Here's my dog Puff. Going to be releasing roughly about two or three videos, kind of dealing with the biochem unit. We'll kind of talk maybe some test strategies, and that's kind of the part that I don't really know right now is what to expect. Obviously, so when you look at the test, I think what they're probably going to end up doing is I'm going to probably guess two or three FRQs, and it's going to be something that is going to try to tie like everything in together. So I don't know if it's going to be one just specifically on biochem and cell energy and so on, or if it's just going to be a conglomerate of everything kind of tying in together and just showing what you guys know. The point is that they're going to absolutely try to take away completely the chance of you guys going through it and plagiarizing or looking up information. That's going to be more based on what you guys know. So however they're going to do that. So again, April 3rd, we'll know that a little bit more. So I'm going to break down the biochem unit. I got three units. Okay, first one, we're just going to talk about the basic kind of structural components, little things like that. Obviously elements and so on, atoms, the bonds and such, and kind of how we tie that into the rest of the class. We'll probably have one on water, and then we'll do another one just on the biomolecules themselves, and that's kind of where we're rolling. And all I'm going to do is I'm just going to kind of follow a lot of our notes for the biochem, and just again, not talk about it one by one, but just something that can kind of tie everything in together for you guys. A much bigger understanding of, I think, what this class was about. We started with biochem. It was relatively tough when you kind of start looking at just the application based part of it. And I think as we go on, I think that became more familiar just because we'd start looking at some of the major themes that were shown to us in the biochem unit itself. Okay. So remember, we kind of started out going through we talked just a little bit about the elements. The major elements that we're going to find inside the body are going to be carbon, hydrogen, oxygen, nitrogen, and phosphorus. And carbon kind of being that main one, because again, that is that element that is basically found in all organic molecules, organisms. It is one of those that every single living organism out there has. And then, the other essential elements that we're looking at obviously are hydrogen, oxygen, nitrogen probably being one of the less essential out of those four. And then obviously tying into all the other trace elements and why we need them and what we need them for and so on kind of comes into play when we start looking at more the nutrition based, which we didn't really get into all that much this year. But again, just kind of tying in the overall elements themselves. But again, as we go through and talk about the elements, probably the biggest thing that we're starting to look at is in the subatomic particle is going to be the electrons, right? Because electrons are the reason why. And there's actually two ways we could go with this. The reasons why atoms are bonding, right? You kind of start looking at the group ones versus the group sevens. You start looking at the groups two, and why do they want to bond? Because again, the amount of electrons that they have that are readily available and are excited, right, to simply go out and bond with other atoms. And that's obviously what's going to create the compounds and molecules that make us up, right? And I think the other part we start looking at with electrons is we start now kind of tying in the whole part of energy. And I think that made a lot more sense when we started looking at cell respiration and photosynthesis in the case of how we can excite electrons and we can actually gain potential energy, which eventually when they fall back to their energy level, their original state, it's going to release that in the form of kinetic energy, right? And so I think that's also kind of a big part of this as far as how we can utilize those electrons. And again, if we go back to the molecular, the molecules that are being formed due to the bonding, that takes us to the theme of structure determines the function of a molecule. I think if we go to more along the lines of the electrons and utilizing their energy, that obviously takes us to cell respiration and also into photosynthesis. And we can kind of look at how we can harness that energy. Now, if we also want to kind of stem off of the electrons and their energy, that does kind of lead us back into also the whole passive versus active transport and potential energy versus kinetic energy that we talked a little bit more about in cell respiration and photosynthesis, and the ways that our body can eventually control or produce energy based on some of the pumps, the ATP or the sodium potassium pump that we have that can actually stockpile energy. And we do this also in the case of the proton or proton gradient in the case of cell respiration. So again, just kind of harnessing that energy as we go through and take a look at those electrons. Now, when we probably talk more biochem, right? Probably the biggest thing we're going to get out of this beginning portion is going to be the electrons and how they're utilized in the bonds. And again, the three major types of bonds that we kind of hammered out throughout the course were covalent, ionic, and obviously the hydrogen bonds. And there was more. When we start getting into the protein folding here, I'll have probably in the third video, you've got disulfide bonds. We've got other types of interactions that they can have with each other, molecules to say. And so, again, there's other types of interactions that can be covered that can actually be seen. But I think the covalent ionic is probably the two major important ones, along with the hydrogen bonds, because of their role within the structure of the DNA itself. And we just kind of, they're kind of part of a lot of different molecules that we looked at. But I think kind of where we go with the bonds, and again, just knowing the difference between the covalent ionic bonds, obviously the covalent is sharing electrons, carbon to carbon based backbones. A lot of our fats, carbohydrates, right, have those carbon backbones. And so therefore, again, you're looking at more of a shared kind of electrons between them. You start looking at more ionic bonds with a given or taking, which is going to be forming ions, which obviously now you've got charges, and that eventually leads us into polarity. And when we start looking at polarity has also been a big part of the human body itself, and looking at polar versus non-polar molecules. And so the polar molecules, again, you have basically like dissolving like, is that basically any molecule that you find inside of a polar molecule, such as water, right, is going to dissolve. Which becomes very, very advantageous to us in the case of the food that we're taking in, the nutrients that we're taking in, and our body's ability to break that down and eventually become part of our solution, become part of our body and absorbed into our bloodstream and used wherever it's needed. And you start looking at the nonpolar and kind of its attributes, right? Obviously, it having the ability to dissolve in nonpolar substances, but I think the big part for us is that it can't dissolve in polar substance, which water is polar. So now you start looking at the fats, you start looking at hormones, you start looking at some of these other non-polar molecules and their inability to break down in our body, which is primarily made up of water. So I think that's also very important as we go through and we take a look. Obviously, the cell membrane and the structural integrity of the cell membrane, being the polar versus non-polar. You start looking at some of the proteins that we're developing, whether they're polar versus non-polar. You start looking at again, just all these different hormones and molecules and stuff that are floating around, and just their interactions with the rest of our body, and what kind of characteristic that gives us as a whole. Now, as we also work in kind of the bonding effect, we also start looking at the shape, and I think this is probably one of the biggest themes that we're going to look at throughout the course of the year. We did look at was how shape determines the function of molecules, and this definitely ties into the whole proteins being produced, aka enzymes, right? In ultimately determining their shape. And a lot of their shape is determined, right? Again, if you kind of backtrack, it's based on the molecules are based on the atoms that make it up and how they interact with each other and how they bond. And so based on their methods of bonding, right, what we end up getting is these very specific structural shapes amongst these molecules. As we have talked about with molecules such as the communication amongst cells. We start looking at antigens versus antibodies. We start looking at basically the medications that we're taking, our body's ability to produce hormones, and how we again can recognize foreign things versus non-foreign things within our body themselves. And it all comes back to the shape versus the structure and the function of those molecules. And so again, I think that's a really key part as we start going through and taking a look at this biochem unit, is just, again, some of those major themes of energy. We start looking at, again, here, shape determining the function. But again, why is that occurring? Why is that happening? And a lot of that always comes back to the bonds. Take that a step back. Obviously, the bonds are happening because of the amount of electrons, valence electrons that we're finding inside or outside of those molecules, right? So I think that's probably the best part, or I shouldn't say the best part. I think that's probably the best way to start this kind of review out is why we are the way we are. Right. And obviously, if we follow the levels of organization, we can take, our body itself, we can take basically any organism that we have discussed, and ultimately we can break that down into molecular form, right? And look at, again, the molecules that are making that organism up, which determines the shape and just the whole kind of physiological attributes that they do have. Okay. So first little bit, again, kind of short and sweet as we go through, but hopefully just give you guys kind of an idea as far as what we're going to be looking at, what I do plan on for the next one. And again, I'm going to do probably in about 5 or 6 minute videos. We'll just kind of break down water again. and eventually working into the biomolecules, which will probably be a little bit longer of a one. But again, if you guys have any questions on any of these videos as we go through, make sure you're asking. If you're looking for something a little bit more specific for me to go through and discuss, please feel free to email me. If you want my phone number, okay, to text me at any point in time, call me up. Again, just email me and I will give that to you guys as well. Your papers are being done as we speak, and so therefore I'll enter those grades in the grade book as well, along with some other hopefully some other things as we go on. We'll kind of see what we get into. But all right, well, I guess we'll talk to you next video here. Hopefully be up here by tomorrow morning, if not a little bit later tonight. I hope you guys are all doing well, and take care.